Good morning, everyone. Today we are from Group B to give a presentation and some conceptual clarity on the topic sequence and series. It's me, the first group member, Prasun Adhikari.
It's me, Nixon Shrestha.
It's me, Pritam Mujal.
Okay, so I think we'll get started off the presentation without any delay. So the first thing we are going to discuss the topic is sequence and series. So we are going to delve into two main questions. Number one, what? And number two, why? So these are the main two questions we're going to discuss. We're going to be discussing today. So number one, what are sequence and series in and of itself? So sequence has two definitions. The classical definition was any set of numbers, if you separate them by a comma, it was known as a sequence. But the modern definition says that there must be a domain and a range. The domain must be defined as the positive as the natural numbers, or some might say the positive integers. And the range, every single number in the range must be consistent within the real domain. So this is the definition of a sequence. However, the point to consider is the numbers must be separated by a comma. So if I say 1, 2 and 3, this is a sequence. But if I say 1 plus 2 plus 3, this is not a sequence. However, this fits the definition of what we call a series. A series is a progression or a sequence of numbers that is separated by a plus or a minus sign, an operator that can do something with the numbers. So that is the definition of a sequence and series. However, we face one issue in our practical field, that is, a sequence need not have any fixed pattern. So we introduce a new term, that is progression. See, the thing about progressions is they must have a certain rule to them, a rule to which they must abide to it. So using the concept of progressions, our study goes further. Number one, we have the arithmetic progression. Number two, we have the geometric progression. And number three, we have the harmonic progression. Assuming that everyone who is watching knows what real and natural numbers are, we are gonna resume our topics accordingly. So the main concept we need to have here is what is spacing, or how these numbers are separated in these three sequences. So number one is an arithmetic progression. Let's say a man earns 30,000 daily. His initial inheritance was let's say 5 lakh rupees. Now, how is his income going to increase, assuming that his expenditure is none? Of course, this isn't a practical scenario, but it's a very good concept for our understanding. So he has a total inheritance of 5 lakh. So this is what we know as the first term of the arithmetic progression. We are given this criteria to start with. Number two, we have the common difference. How is this sequence going to increase? Now, one does not get an exponential salary. One gets a salary each and every month. So the difference is the salary. Let's say 30,000. So now we have a series. For every month, let n be the number of months the person is working. The amount of total money the person is going to have is this term A plus the number of months times the difference. Now this isn't the common formula. The common formula you will use is A plus n minus 1 times B. So this is the general term of an arithmetic progression. The thing to notice is in a number line, if you draw out the terms of an arithmetic progression, the difference is always going to be constant. This value never changes, and that is a primary property that we must understand while studying arithmetic progression. Number two is a geometric progression. This is quite similar, however, we do not have a difference. We have a ratio. Let's say the growth of bacteria in a petri dish. One day there will be 1, another day there will be 2, another day there will be 4. So once a man asked, let's say I take a chessboard, and on the first board I put 1 grain of wheat. On the second, I put 2 grains of wheat. On the third, 4 grains of wheat. On the fourth, 8 grains of wheat. Let's say by the time I reach the 64th box of the chessboard, how many grains of wheat will I have? That was a very genuine question. So he questioned himself. Now, assuming that people did not have idea about geometric progressions back then, they just assumed it was a very small number. They even agreed to give him that amount of grains. However, mathematicians calculated that the number was around 2 raised to the power of 64, right? There are 64 chessboards, and it always increases by a factor of 2. This is the number of grains humanity cannot produce even if they work for 18,000 years continuously. So one thing to understand, geometric progression's growth is much faster and much exponential than we see in arithmetic progressions. Why? Because we are multiplying it by a ratio. We are not adding things, we are scaling things. So that's why the common formula is given by the term is equal to A R raised to the n minus 1, where R is the common ratio. Now A might be the starting value. How many bacteria do you have in a petri dish? Let's say you have 10. Each of them go through cell division. Now another day you have 20. So the common ratio is going to be 2. So let's say A equals 10 and R equals 2 for our purposes. So bacteria, there were 10 initial bacteria in the petri dish. Each and every one of them is growing by a scale of 2. Let's say by day 10, how many bacteria will we have? So it's a really easy process, right? We have 10 bacteria multiplied by 2. In 10 days, 10 minus 1 is 9. Now we have the value of 10 times 2 raised to the 9. 256. So 512. So we are gonna have 5,120 bacteria by the end of the 10th day. So these are the implications of sequence and series. Modeling a population growth, or let's say how much salary are you gonna have, assuming constant expenditure and income. So these are the applications of this topic. Now the third and final topic, the one where people aren't particularly clear about the concept, is harmonic progressions. Now a harmonic progression can be defined as if A, B and C are three terms of an arithmetic progression. If these three are separated by a common difference, then 1 by A, 1 by B and 1 by C, the reciprocal of these values are said to be in a harmonic progression. Harmonic progressions are used in music theory in order to understand how octaves and all these things work. So this is the basic concept behind progressions. Now I will introduce one final concept, then my turn will be done for. That is the concept of mean. Let's say we are given two terms that fit the definition of any one of these three progressions. Now, according in the field of mathematics, there will always be a third number that will fit the criteria, that will be a part of the progression, but that will lie in between these two numbers. So for the arithmetic progression, we have a number that lies between A and B. However, if we insert that number, then A, M and B are going to be in an arithmetic progression. So we need to find that number. That number M is given by A plus B divided by 2 in this case. Now for the geometric progression, remember this is not linear growth, exponential growth. So because we use exponents here, we are going to use square roots in this case. So if the numbers are A and B, for the geometric progression, the mean is going to be square root of AB. And now for the harmonic mean, let's have the concept of how we solve problems in sequence and series. What is a property of arithmetic progressions? That the common difference is common. That means the tnth term subtracted by the tn minus 1th term is always a constant d. So this means for any three numbers, let's say if A and B are in harmonic progression, then 1 by A and 1 by B are in arithmetic progression. Let's insert a harmonic, say they are in harmonic, so let's insert a number in the harmonic progression H. So such that A, H and B are in harmonic progression. This means 1 by A, 1 by H and 1 by B are in arithmetic progression. Seeing that the common difference is constant, we take 1 by B minus 1 by H equals 1 by H minus 1 by A. Now doing some simple arithmetic, we get 1 by A plus 1 by B would equal 2 by H. And further simplifying, we get H equals 2AB by A plus B. So this is how we go about solving problems in this topic, and this is the basic concept behind this topic. That is it for my turn. Now I would like to hand over this to my friend Nixon Chester.
Good morning everyone. Today I am here to help you guys on some exam related questions on this topic. For our exam, we will only use maximum of 5 formulas. They are formula of arithmetic mean and formula of geometric mean and formula of harmonic mean. Here, I will discuss one problem. Let us suppose we have a relation a to the power x equals to b to the power y equals to c to the power z, and a, b, c are in geometric series. We have to prove that x, y, and z are in harmonic mean. We will start by assuming a variable k. Then we will find x, y, and z here. Here. Now, after this, we are going to assume that under this condition, this relation is true. Then, assuming y equals to this, this is the harmonic mean, because they have to be proven as in the harmonic series. Then a becomes x, b becomes z, and this is the relation that is true under if this condition is true. Now substituting the values here. Here from we have to take this for this value here. Now we are going to use the property of log, which is we are going to express these terms in the form of natural log. Here I simplified this into this using the second one of the properties of log. Now this log k cuts this log k, and this expression is cut by this expression, and these two go there. Then it becomes here we are going to use two different properties of log again. We will use the that exponential property of log, which is log 1 by these two becomes the power of this expression, and log a plus log b becomes log ab, and we are going to replace with the variable here, and this relation becomes b square equals to ac, which is the formula of which is the property of three numbers which are in geometric series. Therefore, this relation is true under given this relation is true under given conditions. So we have done our problem. I will write one more formula here. This is the formula of infinite series, infinite geometric series whose common ratio is less than absolute value of common ratio is less than 1. We are going to use this formula to solve one problem. Finding the sum of this series. Here, the a variable is the first term of the series, which is 1, and the common ratio is this term divided by this term, which is 1 by 2. The sum of this series is 2. This much, thank you. I would like to call our next member, Rhythm.
Good morning, everyone. Today I am here to tell you something about objective question of this chapter. And as I have seen from past 4 question papers of this lesson, I have found 4 MCQs which are in common, and those MCQs are question from our book, and they are question number 1, 2, 7, and 13. And I like to tell you the answers of those MCQs which are from our book. So if you like, you can open and see. So there are 20 MCQs in our book. From them, 5 are common, which have been repeated in our previous sequence, and those are question number 1, 2, 7, 13. So the answer of question number 1 is option B. The answer of question number 2 is option B again. Answer of question number 3 is option B again. And answer of question number 4 is option B. Question number 5. The geometric and harmonic mean between two numbers are 10 and 8 respectively. Then the values of A and B are. And the option D is correct, which is 5 and 20. Question number 6. If y is equal to 1 plus x square plus 2 infinity, then the value of x is equal to 1. And the answer is option number C. Question number 7. Sum to the infinity of the series is 15, and first term is 5. Then the value of common ratio is, and the correct answer is option number C. Question number 8. If the AM between the roots of quadratic equation is 8 and GM is 5, then the equation is, and the answer is option number D. Question number 9. If x is equal to 1 plus y squared to infinity, then y is equal to, and the answer is option number C. And the highlighted question number 13. If A, B, C are in AP, B, C, A in HP, then C, A, B are in, and the answer is GP. Thank you very much.